Hi everybody, Stuart here, and today we're going to talk about RAG, metrics, and entropy. Okay, the RAG convention is widely used in measuring kind of anything or communicating to stakeholders in a really obvious and clean way how things are going. It's your basic traffic light, but we look at traffic light oriented metrics as we looked across a whole bunch of projects, and what we discovered was that stakeholders were taking the traffic light way too seriously. And that made the people who are producing metrics take the traffic light way too seriously. And it freaked them out, and it made them want to game their metrics to avoid red or yellow. So we're going to start off by resetting what the RAG convention was meant to be from the outset. And that is that red is you're below par, or you're getting worse. That's all it means. Amber means you're below par, but you're moving up or down. In order to really understand amber, you have to understand the previous RAG state. If the previous RAG state was red and you're yellow, hey, that's an improvement. If it was green and you went to yellow, oh, not so much. And green. And it's important to know that you don't stop at green. You go at green. You continue to improve. And with that in mind, there's a guide that goes with RAG, right? If you read all the different business papers and industrial psychology papers. But I am doing a PowerPoint on YouTube, so I'm going to keep it short and sweet. Focus on trend and not the metrics at the moment. Focus on the trend. Are we getting better? Are we getting worse? If we're not getting better and we should be getting better, or we're getting worse and we shouldn't be getting worse, what are we missing to address that situation? Attitude comes from culture, and culture comes from leadership. And if your leadership are terrible humans, you're going to have terrible results and frighten people, and you're going to have attrition, and you're going to have poor quality, and you're going to have people gaming the metrics. Speaking of which, there are a lot of what I call faux metrics around. I don't think I coined that phrase. I think George T. Doran coined that phrase. He also coined the phrase SMART. We've talked about SMART before in different contexts, but it's really important when we're talking about metrics, right? They need to be specific, measurable, actionable, relevant, and time-bound. And if they're not, then that's really not a metric. That's a faux metric. And the less smart they are, the more they can be gained. And the less smart they are, the less useful they are. In other words, you're collecting a metric and disseminating a metric and talking about a metric that has actual no power to suggest where you could improve. But faux metrics do have a use in organizations, and they're tools of oppression. You don't get the best work out of smart people by being terrible to them. And yet, I keep seeing projects that are run that way. People always ask me, like, oh, what should I measure? And I always answer, well, what are your goals? Because you're going to want to measure different things. And they say, well, there must be like a baseline of things to measure. And I'm like, yeah. There are plenty of software vendors that will certainly tell you there's an absolute list of things. And if you pay them gazillions of dollars, they'll use their software. But so finally, I'm giving in. Here are some that I have found useful over time in helping me figure out the overall health of a project and areas that we as a project team collectively could use to improve. Again, they're not intended to be punitive. And I will absolutely cop to the fact that you could fill thousands of pages full of metrics. But what I've done is I've picked my 6 favorite metric areas, and depending on who's doing the metric categorization, you can arbitrarily categorize them into as few or as many as possible. A lot of people who describe themselves as true capitalists, it comes down to they made money for shareholders or they didn't. That's the only metric that matters, and nothing else does. And that's the kind of thoughtful enterprise leadership that leads to long-term stock gains and a healthy, sustained marketplace. Oh, wait, no, leads to the exact opposite of that. But okay, let's talk about some metrics. We have to measure individual human potential. And I am a developer, so I'm going to focus on developer one. Pipeline success rates, right? If you put code into a pipeline, and most of the time the pipeline succeeds and the software does what it's supposed to, then that's a good thing. PR approval rates. Pull request is what PR is. If your pull requests get rejected a lot, you've missed something. I don't know what it is, but you've missed it. And there ought to be a conversation, again, about helping you follow the shop standard or understand the problem better, or maybe you need a little technical training, or maybe you need something explained. But low PR approval rates for a developer are bad. The sum of all bugs times the severity of each bug by developer is a useful metric. It offsets the velocity metric. Velocity is the ability to deliver business value over time. But in order to measure true velocity, you need to subtract off bugs by severity. So let's say I have two developers, Adam and Jane. And Adam is slow and steady, but his bug rates are really low. And Jane, who's a speeding bullet, but her bug rates are really high, they almost could have the same effective velocity. And I'm not saying that Adam is better than Jane or Jane is better than Adam. They're different styles. You know, one is about getting things out there into the world and letting people beat on it and then revising it. And the other is being very methodical. And depending on what part of the software you're working on, either one of those approaches could be okay. But you can't just give people credit for velocity. You have to give people credit for anti-velocity. And by the way, when I say bug, I don't just mean the things QA reports. I mean things that linters find, things that shop standard reviews find, things that peer reviews find. Any of those things are, this is less than good, and then how bad is it? So support, your support organization, care about the number of incidents times severity. If we have lots and lots of incidents, but the severity is low, that's one problem. If we have the opposite, that's a different problem. Incidents and support calls aren't the same, because support calls are mostly, how do I do this? Or when I clicked on this, it didn't do what I expected. Incidents are automated systems waking you up because something went kabloom. MTBF, mean time between failure, and uptime are mirrors of each other, but they're both worth measuring. And people say, well, if you're measuring mean time between failure, why are you measuring uptime? Since uptime is part of the mean time between failure equation. And the problem with mean time between failure calculations is they can be quite difficult, because if you have scheduled outages from maintenance windows, you have to compute those differently. Uninterrupted runtime is that short is not always a bad thing. If I am shipping a new version of an API hourly or daily, as some very successful organizations are capable of doing, because I ship basically a new one when I've fixed a couple of bugs, and that one's incrementally better than the previous one, versus measuring the mean time between failure, which also considers release durations. So you have to pick one of those metrics that applies to your release frequency. If you are releasing seldom, then uptime is better than mean time between failure. If you're releasing continuously, then the more complicated mean time between failure calculation is desirable. Project velocity divided by cost. Net business value is another way of saying that. NBV has an official way that it needs to be calculated. Sadly, all of the inputs into NBV can all be gained, and many of them are subjective. If you want to start a fist fight, get a bunch of people from finance in a room and ask them what the average loaded cost of a person is by role, and ask them to provide that to you so that you as a business analyst or project manager or project lead or whatever can figure out your velocity divided by the cost. Business continuation. And these all are metrics that involve proofs by somebody else, not you. That's the definition of a proof for the purpose of this presentation. So high availability, survivability, data retention. Believe it or not, it can be a very bad thing to hang on to data longer than you're required to. There is not only an infrastructural cost, but there may also be legal consequences. And if you live in a place that has laws that say, I want you to delete all the data about me, or when our contract terminates, 90 days post-contract termination, you'll erase all the data that you collected about our engagement, contract, project, whatever. So you need to be able to prove that. Data residency, obviously, if you're delivering software and it's going to run in Germany, then they're really insistent that all of the software and data reside in Germany. Same with China, Brazil, lots of other places. And if you wonder why all of a sudden over the last, say, 10 years, that's become a big deal, I urge you to go Google the phrase Edward Snowden and proof of data security. Like, what proofs can you show us that means that you haven't been penetrated, and that if you have been penetrated, what data was compromised exactly? These are proofs that are done by outside people, auditors of some variety, whereas internal security metrics are how many known CVEs are there, critical vulnerability events, and what's the severity to your particular software platform. So if there's a terrible CVE in, say, a database, but your platform isn't using those particular features or has disabled them, then the severity is 0, right? So severity is always in context of what the vulnerability is and how you're using the software that has a known CVE. And then you need to keep track of the mean time to detect, resolve, and contain security problems. And for incidents, that is, something happened, you were attacked, your security was compromised, either internally or externally, you need to measure the severity of that, and that usually gets mapped back to the data security and the traceability of what data or what processing was compromised. And then, obviously, the program cost versus benefit, which is a lot like the project cost, except program costs generally are a roll-up of all the projects underneath it. And so, the spend in different chart of account things and the ability to associate the collective portfolio of projects within your program with revenue. But let's keep track of Charles Goodhart's law. When a measure becomes a target, it ceases to be a good measure. In other words, if you're obsessed with the metric itself, instead of being obsessed with what the metric is trying to tell you, you will trigger Goodhart's law and they'll stop being useful. The other thing is, all metrics, everything that you measure, anything that's measured is going to decay over time and needs to be reset. What does that mean? It means that I start by measuring velocity in this particular way. My project's going to evolve, my people are going to change, my organization's going to change, all kinds of things are going to change. Change is the only constant. So when that happens, I need to exercise the OODA loop. I need to keep track of the effectiveness of the metric over time. Is it still telling me things that are useful? If it's not useful, I need to understand why it's not useful. And then I need to decide how to adjust, drop, or replace the metric. And then I need to act and update my program to change the metric. A few words on entropy by someone more qualified than I, Norman Augustine. Software is like entropy, and all the more reason why we can't just pick some metrics and mindlessly follow them and then thoughtlessly berate the people who don't live up to them. Metrics exist to help us improve and not out of spite. Thank you for your kind attention.